Sulphuric acid is used in a wide range of processes. It is used in metal treatment, for drug manufacture, for paint, and the making of explosives. The sulphuric acid plant in St Helens on Merseyside, owned by Hayes Chemicals, makes about 600 tonnes of acid per day. The plant is close to the local motorway network. At the Hayes plant, sulphuric acid is formed by burning sulphur in a furnace to form sulphur dioxide. In a converter, the sulphur dioxide reacts with more air to form sulphur trioxide. In an absorber, the sulphur trioxide reacts with fairly concentrated sulphuric acid to increase the concentration of the acid. The acid is then diluted to the concentration needed by the customer. Some acid is recycled through the absorbers. Some is stored for sale. This is the Hayes chemical site. The sulphur is burnt in a furnace. Sulphur dioxide passes to the converter. Sulphur trioxide is fed to the absorption towers to produce acid of the required concentration. This is then stored for delivery by tanker. This tanker is delivering sulphur. It's obtained from local refineries where it's been recovered from oil and gas. It's transported as a liquid at around 140 degrees Celsius. The liquid sulphur is sampled before being stored for acid production. Air, the second raw material, is drawn from the atmosphere, dried and compressed. The sulphur is sprayed into a furnace where it burns in the dry air. Sulphur combines with oxygen in the air to form sulphur dioxide. The oxidation produces large amounts of heat. That heat is used to boil water to produce steam to generate electricity. The gas mixture, which leaves the furnace, contains sulphur dioxide and enough oxygen for the next stage. In the converter, sulphur dioxide reacts with oxygen to produce sulphur trioxide. The reaction requires a catalyst, mainly a vanadium pentoxide. This is most effective at 440 degrees Celsius. There are 4 beds of catalyst in the converter. The first catalyst bed converts about 63% of the sulphur dioxide to sulphur trioxide, and heat is produced. The gas stream is cooled before it passes to the next catalyst bed. Hot gas superheats steam from the furnace boiler. The gas stream passes through 2 further catalyst beds and the percentage conversion increases. Between each stage, the hot gases have to be cooled. By the third bed, about 95% of the original sulphur dioxide has been converted to sulphur trioxide. After this catalyst bed, the gas stream is led into the bottom of an absorbing tower packed with ceramic material. The rising gas meets a stream of hot sulphuric acid that runs down the absorber. The sulphur trioxide reacts with the water in the acid to increase the concentration of the acid to about 99%. The gas from the top of the tower still contains some sulphur dioxide and oxygen, and is fed back into the final bed of the converter, after which 99.5% of the original sulphur dioxide has changed to sulphur trioxide. Less than 0.5% of the original sulphur leaves the stack as sulphur dioxide. The 99% concentrated acid is diluted with water to 96%, for example, and this increases the volume of the acid. This extra 3% is the volume of the acid that has been made. The acid concentration is checked by sampling. Besides sulphuric acid, the plant generates a large amount of heat, which is used to produce high-temperature steam and make electricity. Electricity is sold to the national grid. The production process is controlled and monitored from a control room. This dial shows the concentration of acid being produced in one part of the plant. Acid is transported to customers by rail and by road.